Welcome, everybody. I would like to welcome you to this webinar on the changes that we recently did that we made in the most recent amendment to ROSES with regard to providing a more even access to commercial suborbital platforms, providers, and thereby increasing our available suite of launch platforms that we think will allow greater science. I'm Thomas Hams. I'm in the astrophysics division, and amongst other things, the suborbital lead in astrophysics. We have also present here Dominic Benford, who is the overall APRA lead. And I'm going to go through this part that deals with the APRA solicitation, and I'm going to keep that short and succinct, and then hand it off to Lucas because he's going to talk about all the new launch platforms that we have now integrated into APRA, and that should be really the star of the show. I'm going to be focusing on the solicitation, so the text that you see here is lifted from the solicitation. I encourage you to read that, but I will highlight those items that are changed recently in ROSES 22 and are important to note for this deadline, and or those that are in reference to commercial platforms. All right, so you should have received on October 5th the 55th Amendment to APRA 22, which, amongst others, announced this webinar and also deferred the deadline for both APRA and SAT for the mandatory NOIs to November 4th, 2022. In ROSES 22, all suborbital investigations, be it rocket-powered or balloons, are required to have an NOI stage payloads requirements document uploaded to the NOI, mandatory NOI, and the templates for that PRD can be found under other documents on the NSPIRE's website. And the proposal, the payload requirement document will be later on discussed in full by Lucas. So the proposal due date for the full proposals is unchanged and is the 15th of December 2022, and all proposals must be accompanied by a final payload requirements document. So a brief overview of a ROSES. ROSES is, so let me move this around here. Sorry about that. ROSES is a very broad and part of the Omnibus ROSES solicitation, and it solicits basics research for proposals for investigating that are relevant to NASA's astrophysics and astronomy, and includes research over the entire range of the electromagnetics, gravitational waves, and particle astrophysics. Awards for suborbital investigations can be up to 5 years, but shorter are typical. The emphasis on this program element is on technologies and investigations that advance NASA's astrophysics missions and goals. APRA investigations may be advancing all technology level, the full range of technology levels from TRL 1 to 9 through 9. And so this is different to SAT, the strategic, that has a specific entrance and exit requirement. So this is overall to ROSES. I'm sorry. Here we go. The category for proposals that may be submitted should be address the best possible of either advancing the state of the art of detectors that are applicable to future space missions in astrophysics, science and or technology investigations that can be carried out, and this is on suborbital platforms, balloons, sounding rockets, CubeSats, and others, and supporting technologies or laboratory research that are directly applicable to space astrophysics missions. And accordingly, we have these 5 categories down here, and I will be specifically talking about the suborbital class investigation. if you, and it's covered on the next slide, if you have, for example, a detector development, something that's focused on detector development, but it includes a suborbital flight, please categorize this as a suborbital investigation. The same is true if you have laboratory astrophysics and want to do a laboratory astrophysics measurement, and it entails a suborbital flight, that would also then be a suborbital investigation. Again, I want to stress that proposers must upload an NOI stage payload requirements documents along with the mandatory NOI that will allow NASA to make an NOI stage assessment of what is the appropriate launch provider. The opportunities that are offered by suborbital investigations are that they provide a unique opportunity not only to execute intrinsically meritorious science investigations, but also the technology advancement that we discussed earlier that is applicable to future flight missions, supporting technology, and also preparing future leaders for NASA's flight missions, such as early career of researchers, graduate students, as well as engineers. Here we go. The suborbital platforms, this is now a broader palette to choose from. We have the NASA's own sounding rocket and balloon, and I'm not going to go into that in much greater detail, but the links can be found here. And so what is new in ROSES 2022 is that we have incorporated and put on a streamlined and put on a level footing with NASA's own, the commercial contracted suborbital flight providers that are provided through the Flight Opportunities Program in the Space Technology Mission Directorate. And so we expect that with this diverse set of platforms, smaller payloads, with a smaller cost, can take full advantage of these capabilities of higher flight cadence, and provided that these proposals are meritorious. Ultimately, we expect that this platform suite that is now expanded and complementary will lead to greater science yield and impact. I want to point out that NASA is reserving the right to select the final launch provider, though the proposer has the ability to express a preference. The NOI stage payload as a payload requirements document is for the initial assessment and with the NOI, and then we have a final payloads requirements document that must be submitted with the full proposal, and that will provide the final assessment of the launch provider assigned by NASA. So here are some additional points that are specific merit criteria that are specific to APRA suborbital investigations. And so in addition to the general merit criteria that is intrinsic merit of science, there's also the degree in which the advancement of technology readiness of a detector supporting technology is advanced, and the degree to which the readiness of early career research, the future leaders of NASA's future missions, are advanced. And proposers should identify which one of these three categories is the main focus of it. Is it the science investigations, technology development, or training of the next generation? Here's an overview of the, we have APRA 15 through 20 here in this table, and then we have suborbital investigation, detector development, supporting technology, and laboratory astrophysics. And as you can see, suborbital investigation have always been a core component of APRA. This is a little bit of boilerplate. It's an eye chart. I refer you to the solicitation. I had it included here for completeness. And then finally, in APRA, we have different portfolios or that are listed, or disciplines that are listed here, and the respective technical officers. So if there are any questions to specific components, then you should reach out to your respective discipline representative. And I think that closes it for me. I would ask you to hold questions until we are done. And I would like now to turn it over to Lucas to tell us more about the platforms that are now available, more streamlined to proposers in APRA. And what I failed to mention early on, I'm sorry, is that this is also, of course, that should have been on the first slide. Many of the details about APRA, about astrophysics, aside, the path that we have chosen in ROSES for commercial suborbital is also applicable to, of course, our friends in heliophysics. LCAST, for example, came out with an amendment, and there we will follow the same path, where we have an NOI with a NOI stage payloads requirements document, and then a payloads requirements document for the full proposal. And so these things are probably applicable to both APRA and LCAST. Lucas, let me stop sharing and hand it over to you.
Okay, thanks, Thomas. Let me see if I can create a slide here. Slides. Okay. Hopefully, everybody can see my slides there. Thomas, thank you so much again for the introduction and for the opportunity to be here today. It's great to have a chance to be here and talk a little bit about the work we've been doing to add the commercial suborbital platforms into the current ROSES 22 solicitation. Particularly, these additions are, as you just mentioned, are certainly applicable to both APRA and the heliophysics LCAS programs. So my name is Lucas Moxie. I work with the Flight Opportunities Program, and I'm also serving as the lead for the Commercial Suborbital Innovation Initiative with SMD. So I wanted to start off by mentioning that the goal for these slides is really twofold. First is to highlight the newly incorporated commercial suborbital platforms that were added to ROSES 22. And secondly, to provide some guidance to the suborbital aspects of the application process for both of these APRA and HLCAS. As you mentioned, they are following the same application process, so we'll briefly walk through that through the presentations today. So basically, I want to start off by mentioning that SMD is seeking to build on the advances achieved through the NASA's sounding rocket and balloon programs by incorporating commercial suborbital platforms into the SMD's portfolio and to further support the needs from the investigators within ROSES. So one of the objectives is to do this by means of to complement along the current platforms available through the traditional NASA provided platforms. And really the goal for this is to complement the currently available traditional NASA provided platforms that are available to SMD researchers through the Balloon Office and the Sounding Rocket Program Office. And just as importantly is to really seek to augment the number and type of suborbital platforms that are available to the suborbital research communities. And the way to attain this is by basically NASA is seeking to leverage off the tools and resources available within different mission different directorates. For instance, SMD is working specifically with the Space Technology Mission Directorate, in particular the Flight Opportunities Program, to leverage the current contractual mechanisms that Flight Opportunities has for working and gaining access to some of these commercial suborbital platforms. So this really helps open up several new avenues for potential research. So departing on that, I wanted to just briefly mention what to give a little bit of more context, what Flight Opportunities is. So Flight Opportunities is a program within STMD that seeks to enable suborbital flight testing of promising technologies or investigations that require suborbital environments. And it achieves this by means of commercial flight providers. And Flight Opportunities has a contractual mechanism called IDIQ, which stands for Indefinite Delivery, Indefinite Quantity contracts, commercial contracts with multiple companies. So this allows the Flight Opportunities to leverage off the different type of vehicles and the different capabilities that each has for accommodating a particular research or technology payloads in order to conduct these suborbital flight tests. And just as an example, here's a picture of one of the platforms from Blue Origin in this case that is routinely used by Flight Opportunities Program. So for awareness, the Flight Opportunities Program has 4 primary types of vehicles under IDIQ that it can leverage by means of its IDIQ contract mechanisms. I want to highlight that not all of these are available for ROSES, but I do want to mention that these exist in general. I'll talk in a second of what specifically is available for ROSES 22. But in general, Flight Opportunities has these 4 different types of vehicles available, each very unique characteristics and flight environments. So we have rocket-powered vehicles, we have high-altitude balloons, and we also have the vertical takeoff, vertical landing vehicles, and parabolic flights. So in addition, let me see, is it still showing? Okay. So these are the primary.
You're advancing the slides. Thank you.
You can see the slides? Okay, perfect. So these are the primary vehicle types that we have. Having said that, there's different types of instruments or elements that are tested as part of these suborbital flight tests through Flight Opportunities. So of course we have sensors and instruments which are certainly applicable to APRA and HLCAS. We have mechanical systems and many others that are shown in this slide here. But again, just want to highlight that there's multiple aspects of technologies and instruments that come into play that can be tested by means of these platforms. So circling back to specifically to ROSES 22. So for ROSES 22, SMD is leveraging the IDIQ contracts for 5 particular platforms. So we have 3 rocket-powered vehicles, which includes UP Aerospace, Blue Origin, and Virgin Galactic. And in addition, we also have the 2 high-altitude balloon providers, which includes Worldview and Aerostar. So this slide shows a nice summary of some of the different capabilities that the different providers can attain and how they could be of use for the research community. So profiles 1 and 3, shown in blue and green, show the rocket-powered vehicles, and they show approximate altitudes of at least 80 kilometers that allow for multiple minutes of microgravity environment for research applications. Also in some instances, depending on the flight provider, there's possibilities for allowing for payload rejections or releases from the main vehicle for re-entry applications. Having said that too, also want to mention that because, as we talked about earlier, because there's different types of vehicles, for instance, here, some vehicles allow for incorporating payloads internally within a pressurized environment, benign environment, where others allow for both internal and external, or just external, depending on the vehicle. And then lastly, we have another profile in red, which represents the high-altitude balloon profiles. This is approximate altitude shown here. It's not necessarily specific. It can vary depending to the needs and capabilities of the provider, but it reflects the typical high-altitude balloon profiles of ascent to about 30 or more kilometers in altitude, and varying degrees of float time, followed by descent, and that descent phase could allow for potential payload ejection as well. And again, these three profiles, which are shown here, are applicable to these 5 providers that we were mentioning earlier, which includes Blue Origin, UP Aerospace, Virgin Galactic, Worldview, and Airstone. So I wanted to just show some brief slides for gives a highlight of the different vehicles that are on contract through Flight Opportunities and available through SMD for both APRA and HLCAS. Certainly encourage any interested researchers, if there's particular more details that are of interest, the researcher can certainly reach out to these companies directly, and they will be able to provide all the information directly to them as well. They're very specific and comprehensive documentation for the capabilities and availabilities for each of the vehicles. Capacities. So one example here is we have Blue Origin. Blue Origin is a rocket-powered vehicle, and it targets altitude of approximately 100 kilometers. It allows it for about 15-minute flight time approximately, but primarily allows for this 3-minute, about approximately 3 minutes of microgravity, and it allows for carrying payloads both internally or externally. Internally, for instance, there's multiple options for different capacity and volume requirements for payloads. So there's a single locker, or double locker, or multiple, or a combination or custom solution for those. So there's and these lockers are included within the crew cabin, which allows for a pressurized environment for those instruments. Another example is Virgin Galactic, comparable in nature with the previous one. It's a rocket-powered vehicle, a little bit longer flight duration, however, also an altitude of at least 80 kilometers, with a target microgravity environment duration of between 2 to 3 minutes. And just like in the previous case, there's multiple solutions for payloads that could be carried. Typical configurations are single lockers, double lockers, but there's also flexibility for different configuration as needed for accommodating a payload. Another example is UP Aerospace. UP Aerospace provides a vehicle more in line with the familiar as a sounding rocket vehicle. This particular vehicle reaches approximately 115 kilometers altitude. and allows for about 4 minutes of microgravity environment. Typical payloads are about, it can accommodate is approximately 36 kilos, and it can allow for internal and also potentially external payloads as well. And again, as I mentioned earlier, I certainly encourage anybody interested to learn more about what the capabilities for each of these payloads could be, to reach out directly to these companies to get the full comprehensive information and documentation for each of these vehicles, for each vehicle. And then moving on to the hydrogen balloon platforms, we have Aerostar, and they have the zero pressure balloon vehicles. And these are very flexible vehicles that can allow flights of different durations. They can be anywhere from hours to longer duration flights to days or so. Can be more than 30 kilometers altitude, and with a wide variety of payload capacity. Can be 45 kilos, but heavier can certainly be accommodated. And of course, just as mentioned for other vehicles, these can also allow for, release of release of payloads, as shown in this picture, that can be used for testing re-entry technologies or instruments or sensors. And lastly, one also mentioned for hydrogen balloons, we have the vehicles provided from Worldview, also that can be very flexible in nature, can be long duration flights or short duration flights as needed according to the payload and investigation requirements. Target altitude can certainly vary, and just like the amount of weight mass that the vehicle can carry. And there's different types of vehicles, and again, like in previous cases, certainly encourage anybody interested in really learning all the details about each of these vehicles to reach out to these providers, as included in some information here for the contact information. They will be able to provide the specific vehicle documentation, which really details all the information and capabilities for each. And then also wanted to mention, shifting gears a little bit, I wanted to mention some of the important guidelines for APRA and HLCAS solicitations. So as Thomas mentioned earlier, there is some important things to keep track if there's an interest for the suborbital aspects for this solicitations. So particularly, first and foremost, I want to highlight researchers to ensure they view and follow all the guidelines that are included in section 8C of the ROSES summary of solicitation. There's a lot of valuable information there, multiple aspects are covered in regard to suborbital research, so definitely encourage proposers to study that section. Also, as Thomas mentioned earlier, so both for APRA and HLCAS, there's going to be a mandatory but brief, the good news is very brief, NOI stage payloads requirements document. And this is a very short form and very, very short form that provides some very basic information about the envisioned payload needs and some examples. And next slide, I'll give a brief example of what that document looks like. But it provides some very basic information that allows NASA to understand the needs of the researcher and get a better sense of what could be potential vehicle candidates. If these could be either from the traditional NASA-provided platform, or it could be from a potential commercial vehicle that, again, through the Flight Opportunities Program. So again, it's just to provide some insights of what the researchers predicted envisioned needs, preliminary needs might be. And some of this information includes like, okay, what kind of vehicle type is going to be needed, what the dimensions of the payloads are envisioned, what mass, launch requirements, flight dates, envisioned flight dates, minimum, maximum altitudes, etc. This is a very, very high level overview of some of the expected needs and requirements for these research payloads. And again, so it's going to be used by NASA to do a preliminary assessment to understand what could be the most compatible suborbital platforms to accommodate these needs. And certainly want to highlight that this information is not used as part of the evaluation process. It's just used just to understand what could be potential platforms to help accommodate the needs for these payloads. So following the NOI PRD, so following the NOI stage, there is going to be also a mandatory proposal stage payload requirements document. And just like in the previous example, this is also going to be available through NSPIRES. And in this case, it's can think of it as the next step to collect a little bit more detailed information of what the payload is going to need and what the mission requirements are going to be. So to really get a little more detailed information and to help better understand the best compatibilities with the different vehicles available to NASA. And then also one important note is to mention that there's no quotes or cost estimates related to flight services should be included in the proposal. So proposals should not include any information regarding this. And then lastly, to mention that if selected for a commercial flight platform, NASA Flight Opportunities will be working with the PI. We're going to have a campaign manager that will serve as a liaison between the PI and the commercial flight provider. And here's an example. This slide shows that basic preliminary PRD form, payloads requirement document, which outlines some of the basic information that's envisioned for the payloads. Again, examples include what type of vehicles, orbital vehicles envisioned, the approximate dimensions of the payload, mass, how much power it might be using, and then other requirements such as launch location, flight date requirements, if there's any pointing requirements for the payload, et cetera, et cetera. So this is a short form that just to get that preliminary understanding of the payload itself and its needs. And start to kind of conclude here, just wanted to mention to the community that there is Flight Opportunities typically has a monthly webinar, community of practice webinar, where Flight Opportunities program invites different panelists every time to talk about different topics that are of help and can be of help and assistance to both seasoned and new suborbital researchers alike, to provide information about how to navigate the process for preparing and executing a suborbital flight. And there's been some really valuable webinars. These are all recorded, so they're all available through the Flight Opportunities website. I certainly encourage everybody to attend, or also register to the newsletter that the Flight Opportunities regularly puts out that has information for these webinars. But there's a lot of lessons learned and a lot of valuable information a lot of perspectives and insights from researchers that have flown that can be of great help for us preparation for upcoming research investigations and of interest as well. And then lastly, just wanted to share a little bit more information about what Flight Opportunities program itself. That here's a link to the website, but also some contact information if there's particular questions regarding commercial suborbital launch vehicles and the ROSES 22 solicitation. My name is there, Lucas Moxie, and my email. I'd be glad to help answer any questions that may come up. And Thomas, I think that's all I have.
Yeah, thank you for that. I think there were some, there were some issues for some to see the slides. I think what we're gonna do is put these slides on the science.nasa.gov suborbital website in a collated fashion in a timely manner, so that they're there for you and that the web links contained therein are also accessible. With that, let's see, are there questions? Andrew, do you want to open the floor for the question and answer session?
Alrighty, there are no questions asked so far, but if anybody does have a question, please raise your hand, and I will go ahead and unmute you. So we'll go ahead and start with Joe.
With the RSD payload and Amir Hurst as the PI. We've been thinking about experimenting with a couple other opportunities with this payload regarding new instrumentation, mechanical systems. This would require a suborbital flight based on the time requirement for microgravity. And we're wondering what the current operation standards are for a manned suborbital. At the moment, there's no way we could get this to be an automated system.
That the ability to have a tended payload is probably in your wheelhouse, Lucas.
Copy that, thank you.
I see a question here regarding NOI. So just want to mention so the forms are identical for both HLCAS and APRA. So all PRD, both the NOI stage and the full proposal stage, those the forms are different from the NOI stage and the full proposal stage, but both of those two forms are going to be identical for both HLCAS and APRA.
Lucas, did you hear the question that was previously asked?
No, sorry. What I did, I thought, sorry, maybe I missed. So regarding the suborbital and human tended?
Yes.
Oh, yeah. So there is at this point there is no specific opportunities for that. There is yes. So I guess that for now, for the time being, that's not applicable for ROSES 22.
Copy that, thank you. I'll keep my eyes peeled.
Okay, I'm going to go ahead and unmute John next. John, did you also submit their question in the chat? Is that the same question?
So Exos has a current ready vehicle. We've made upgrades to it. The FAA is actually classifying our license as the same vehicle. So we have a flight on April 26th of 2023. Of course, still tentative, but that's probably our date. And then we are going to turn that vehicle around and do a reflight, having proven the vehicle with a NASA payload that we have from our prior campaign under Ready. Who do we talk to about that? And basically how we certify that vehicle after the flight, that yes, we achieved greater than 80 kilometers, and we are now qualified just a couple days later for that flight, short of having Paul DeLeon and NASA out there while we're doing it.
Yeah, so I can take that. Hi, John. So yeah, so that's a very specific pointed question. So I think it's something that you know, it can be discussed directly with the Flight Opportunities Program. I'd be glad to help route that question for you.
Excellent.
Yeah.
And then is LCAS and ARPA, those are two separate proposals we have to submit, or NOIs we have to submit? Am I correct on that? We fill out the form for ARPA, and then we also put in NOI for LCAS?
Yeah, Dominic, you want to take this?
Sure, I'll take this. So APRA and LCAS are two separate programs depending upon the science investigation or the technology development you're trying to achieve. So it is likely that a proposer would only be submitting to one or the other, and that you would submit a PRD for each proposal that you submit. So certainly if you're submitting both to APRA and LCAS, you would submit two PRDs, but also if you submit two proposals to APRA, they should each have their own PRD as part of the notice of intent and as part of the full proposal.
Yeah, we're actually the flight provider, so.
I thought that might be the case.
Yeah. Okay. Thank you.
Alrighty. Sorry, go ahead.
Well, so for clarification, so the proposals here are for science investigations that want to utilize platforms available within the solicitation. For the question that was just previously asked with regard for flight provider, I think Lucas might correct me if I'm out of line here, but I would suggest you should reach out to the Flight Opportunities Program to talk to them. So this is for science teams that want to utilize the platforms available. We have changed the process, allowing as more streamlined access to commercial providers. If you're a commercial provider, then I would encourage you to talk to the, I would assume it is Flight Opportunities, and see what is required to get an arrangement with them.
Yeah, Thomas, I just wanted to confirm, yes, I think that's more specific to Flight Opportunities discussion. So if we can discuss that offline by email or such.
Alrighty. Thank you, John, and thank you, everyone. The next question is going to be coming from John Moses. So I'm going to go ahead and unmute him so you can go ahead and start talking, John. John
I'm not
Moses.
hearing anything.
There we go. Now we can hear you.
John is texting that he's still muted.
Hello.
Hello.
Oh, he's there. Hey, John.
Okay.
Hear you.
Second time's the charm. So I'm the LCAS program scientist, and just wanted to make a bit of a clarification. I don't know if it matters in the end, but for the APRA and the LCAS solicitations, the NOIs are actually different. It's this payload accommodations form that's the very same. And so, for example, you certainly needed it's certainly expected that you would have a different science emphasis, either on the heliophysics or on astrophysics, although we do have overlap, right? It's possible to put something in there on, analogs and those kinds of things. But you need to slant the, you need to satisfy different criteria for the specifics of the proposal. And in the LCAS, we've been emphasizing the science traceability matrix as the quickest way to communicate ideas of what you're trying to do and what you'll need for your mission. And so we put in the added requirement of a science traceability matrix as part of the NOI, understanding that this is an initial stab at it, and things are likely to change between NOI and the proposal. But just to be clear, the APRA has not added that to their requirements for their submissions of their NOIs. And that's all I wanted to say.
Dan, as always, thank you for joining. Thank you for contributing. And it was neglectful of not mentioning you as the corresponding counterpart to heliophysics. You're Dominic, essentially the lead for LCAST in heliophysics. So thank you for your contribution.
I prefer to be in the background anyway. Eminence Gris is my motto.
That's quite all right, sir. Thank you.
That is all of the hands raised and questions asked. Does anybody else have any additional questions?
If not, I would encourage folks to look at the science.nasa.gov suborbital website soon, where we will have this presentation, and you will also find there Lucas and my email if further questions would come up later on.
Actually, there is one in the chat, Thomas, from John Wong
Yes.
here. You may want to
Yes.
answer.
Yes, I just saw that coming up while I was speaking. So I was trying to be careful. So this is a question is that does this not apply to CubeSats? And that is correct. This payloads requirements document is not applying to CubeSats. I hope I was sufficiently clear to say that is for rocket-powered vehicles, rockets, and balloon payloads. CubeSats are suborbital class missions, and they're not required to have the PRD. That's feedback that we're going to use in the next round of APRA. Thank you for that. All right, any more questions? If not, as I said, we'll have the slides soon on the website. You will find there also Lucas's and my email if there are follow-up questions. Andrew, I would hand it then back to you for closing remarks. Thank you very much for everybody attending.
Alrighty, thank you, Thomas, and thank you, Lucas and Dominic, for joining us today for this town hall, and thank you to everyone who is an attendee. We appreciate you joining us. With that, we are going to go ahead and end this town hall, and you will also find the recording available in the same link that Thomas has been mentioning about with the presentation and his emails with him and Lucas. With that, have a great rest of your afternoon, everyone.
Thank you. Bye-bye.
Thank you, everyone.
Thank you.